Friends and colleagues, please welcome to the stage Jim, Dave, Chris, and Elliot.
Guess I'll wait for the door to be closed. You all hear me okay?
Yeah, that's good.
Oh, fantastic. Good. Well, you chose the sessions well. I know there's other parallel sessions going on, but you clearly picked the best session. So hope you're feeling lucky and you can carry that luck to the casinos later on as well. I know it won't be carrying with me. Hey, look, the title of this is around AI and power dynamics. How do we actually kind of manage the problems that are facing us today? So there's a lot of discussion. I think we're beyond the words of talking about hype in AI. There's a reality to it. But this session, what we really wanted to do is we wanted to kind of cover the reality of two topics. One is, how do we balance the demand and growth of AI compute, along with the realities of the grid infrastructure? That's the fundamental nature of this discussion today. What's interesting, we were joking backstage that, hey, we used to all talk about, 10, 30 gigawatts as like a huge data center. That's like not even like in the vernacular today.
30 gigawatts.
30 gigawatts. I just said 30 gigawatts. Yeah, 30 gigawatts is about right. So it's that whole dimension is kind of like all chained. And a lot of it is being driven by the need for digitization, which is still happening. We're still using cloud. We're still streaming data, but there's a fundamental underlying driver of AI workloads. AI workloads in all of its forms. In real now, and I kind of call it that we're at the use of AI right now. And so organizations like Schneider, like some of yours, we're on the data that we are trying to find value in AI and how it can bring efficiency to our business, how it can help us be more creative, more innovative in this space, as are states and governments in that space in scientific discoveries as well. So that's the underlying picture. There's a growth for this AI. It's not just AI because we like to create pretty images. It is largely around the fact that there is some value that we're just beginning to sense in that space. So I want to talk about this in kind of three topics, with our really interesting panel. I'll let them introduce themselves in a minute. But we're going to first talk about sort of the demand surge. Where are the bottlenecks and can they really be overcome? Then we're going to shift gears a bit to get the perspective on innovation and efficiency. And here we're going to ask more around kind of, what innovations and efficiency priorities should data center builders, owners, operators, and the ecosystem really be considering in this space? And then I want to switch gears to talk about the role of having a firm strategy and partnerships, and how that strategy and partnership, particularly along the lines of thinking about access to energy, siting, all those dimensions, how that actually can really help drive efficient deployment of data centers overall. Our goal is to equip you with insights and maybe some actions that can take. But if you're just in the audience trying to understand more about AI, you picked a good place to talk about. So look, before we get into too much detail here, it's be crazy to not let these guys give a few words about who they are, what their company is, and you'll get a sense that each is coming in from a little bit different angle, which I think is going to cover the richness of this conversation right now. So Dave, tell us a little bit about yourself and Uplight.
Yeah, thanks so much, Jim. I'm Dave Sheehan, VP Industry Solutions at Uplight. So Uplight, we're coming at it from the software side, and mostly from software that enables load flexibility and flexible interconnect of large loads. So think about like virtual power plants, demand response programs. My company's software helps empower that. So clearly, when we're looking at data centers and a lot of the load growth that we're seeing, companies like mine can provide some additional tools that enable managing around those peaks and to leverage flexibility that already exists, and to also interact well with the utilities that sometimes make the process take a little longer.
Chris
Crosby. Mike's not on, I guess.
They'll find you. Yeah.
Well, I'll talk loud.
Yeah, you're good.
So, Compass Data Centers. We are a campus provider of data centers to some largest companies in the world. That's what we do.
Yeah. Good perspective. Elliot?
So Elliot Aduda, I'm the president of Hypetech Construction. We focus really on building data centers, and these days it's really around AI data centers. Like Chris mentioned, these are very large campuses, 100 megawatt plus, and even gigawatt requests. So excited to have this panel with you guys.
Yeah, it's a great place. You kind of software demand management on the grid capacity. You've got owner operator of data centers and builders in the space. So you got a crazy mix here, and I think that's gonna add some texture here. So look, let's talk a bit around the first piece, which is around the demand surge. And look, no matter how you look at numbers, I don't care if you're looking at Accenture, at DOE data, everyone is showing the fact that data centers as a percent of the total electricity consumption in the U.S. is growing. There was projections of maybe it was 6% or 5% in 2024. Now we're talking about maybe 6% in 2027, maybe up to 16 to 23% in 2033. Look, it's just kind of keeps changing with implications that it's upwards and to the right always. Look, Chris, I'm really trying to understand. Are we underestimating or overestimating this, and that impact, and what are really the bottlenecks that you see, and first of all, on the reality, a little bit around the bottlenecks you see that are barriers to maybe meeting that demand.
Well, we can talk a decent amount about power on that front, and there's a lot of misconceptions about power and energy in the United States. I'll speak to specifically here, but it goes for Canada, it goes for Europe, it goes globally as well. One thing is the grid's only really used about 50 to 60% of the time at what it's designed for, and we only have a few hundred hours in which in every community where the grid would actually need to have full use of the grid. And so that's one thing we say we don't have enough power. We actually have a lot of power. We don't have access to a lot of the power. And a lot of that has to do with the regulatory environment, both from public utility commissions as well as from legislatures, as well as from the emissions permitting with the EPA and the environmental quality. So what we've got is we've got something that's really focused on the utility companies are doing bad, data centers are doing bad. Why can't you guys do better? And we're at this interesting inflection time frame right now where we're trying to figure that out of how can we make things work well with so many other things we do from a community standpoint with the involvement and the investment of what's going on. We were just talking about it earlier. If you look at GDP growth this year, it's data centers, AI and data centers. And that means the amount of CapEx that's going into hard goods hasn't been seen in decades here, right? And so you're looking at massive amounts of investment. And there's some barriers that are out there that are artificial in nature. And then there is the hype cycle. And the hype cycle is two guys in a van. I know when one of my buddies I play golf with, a home builder, sends me a picture of a pond, a wire, and some land, and says, "Hey, Cross, another data center." Probably are in a little bit of a speculative bubble as it relates to that stuff. So you've got real demand. You've got, AI is transforming the economy from an industrial revolution standpoint. Hopefully everybody believes that. But where are we in that cycle? Are we overhyped in some areas, but long term we can't get enough of this infrastructure? This is like the railroads all over again, electrification all over again.
Yeah, I think it's insightful to understand that. Yeah, you hear words, and sometimes it's overwhelming to understand kind of all the gigawatts and investments. But there's a trend that's always up that's a little bit different, as Chris is pointing out, very much infrastructure related. And yes, there's better collaboration that has to happen, on terms of utility data center side as well, which we'll talk more about later as well. I also want to give a perspective just, to our friends up north, although it really isn't unique. It's, where there's it's very similar here. But Elliot, so in Canada, if you just think about the rate of growth last year, I believe that I think TD Cowen was talking about the fact that there was about 5 gigawatts that was built in 2025. This year it's 6.2 gigawatts. Classic, mid 20s to 30% growth in that space. Tell us a bit around how Hypertech is staying ahead of this demand, and how your strategies are kind of benefiting your customers and what you're doing in that space.
Sure. So for us, the construction time frame is not the problem. We build between 9 to 12 months, so that's not what's going to come and block a project. In Canada, it's a little bit different. Utilities are owned by state and federal agencies. So political, working with the political groups, working with the government is extremely important. Now, the good news for Canada is in the past couple of months, they put in a minister of AI, fully dedicated to understand that, Canada's behind. Canada's behind compared to the US, and we have a lot of ground to gain. And they're putting real steps forward to get that happening. So we're going to see a lot of growth in Canada in the next couple of years. with this new administration pushing for that. So I'd say the tidbits is really making sure you're very close to the political system, or else it's kind of dead in the water. You'll spend a lot of time and effort and not really get anywhere.
Yeah, it's good. So I think I want to now shift gears just a little bit, talk about infrastructure readiness, and I want to give Dave a little bit of a voice here, but maybe follow with Chris a couple of backup kind of what he said earlier. So given that the pace of AI expansion, really are utilities, regulators, and data center developers aligned at that fast pace to meet the future power needs? And where do you see the breakdowns in that coordination today?
Yeah, I think to start, utilities and regulators, they're coming from a very, very long-term time horizon, right? They're planning for years in advance. They're planning, again, for those peak conditions that really comprise very few hours of the total grid loads over a year. Yet, on the other hand, we've got all of the work that we're trying to do that is being done like immediately, right? Very short term. So part of the challenge is that by the time, it takes a long time for the regulators and utilities to catch up, and they're also thinking about it from their existing mindset of building using things and approaches and processes that they're used to today. Now, if we think about like a company like mine and some of the load flexibility that exists, there are solutions out there today that help mitigate a lot of these challenges. But the problem is it's hard. Like, we'll have utilities come to us that want to capture some of this load flexibility and make it easier for a data center to interconnect, but they can't because there's regulatory issues, or maybe the way that they would be able to structure a demand side management program wouldn't actually work with the business model that the data center is operating under, because maybe it would necessitate, let's say, focusing on like compute versus, let's say, some of the other flexibility that may not be compute limited at the data center. I'm thinking things like, tapping maybe some of the backup generation resources that might have carbon emissions as an example, right? So I guess that's all to say, and to sort of summarize that everybody is approaching it. All these stakeholders are approaching it from their own mindset. And when you approach the same problem from a very different mindset, you often are coming up with like solutions that are not as optimized for the outcome that we're trying to achieve. So I think what we need to do is balance the creativity of how we can work within today's regulatory structures, but also help lead the regulators and utilities in a more like collaborative way.
Yeah, Chris, there's definitely a lot of common sense things that can happen. I think one of the big things we're trying to do is try to educate folks around things. Yeah. We do have capacity in the grid. When you utilize infrastructure, the cost for the consumer goes down. It doesn't go up, because more of the infrastructure is getting utilized and paid for by someone directly. And we've got some need for some refreshes on some things, because you can come with a really great idea. And let me give a moral fabric issue from it. Storm Uri in state of Texas, where I live in Dallas, there were 12 people that died from that storm because there was no law and there were threat of criminal penalties if someone like us as a data center operator were to go off grid because we knew there was a storm that was coming and it was going to put pressure on the system. But because you can go to jail from the EPA, because apparently the CO2 for tomorrow is worth more than the life today. That's not common sense. And these are the types of things that people just generally don't know. We can come up with a wonderful idea and it is shut down because of things you'll go, wait, that doesn't make any sense. HVO, the same thing if you've gotten a Chick-fil-A sandwich that it's cooked in, is what we use instead of diesel. It's way less NOx, way less. It's a circular fuel in Europe. It's politically incorrect in the United States. The EPA tells you, nope, I'm sorry. If it could be diesel, then it is diesel. And they say that your emissions are going to be the same. There's inanity in our systems. Canada's even worse on it. And, it's an even tougher environment. There's just inane things, and average people don't know it.
Yeah. I think that's, some of the things that we can gather here is that, look, remember, there is capacity. And with a little bit of regulation movement, allowances, and some common sense, not everything, but there's a lot that actually can be resolved.
Deregulate. I mean,
yeah, you can't back away from it. It can't be the Wild West. We still have reliability. Yeah. And that's, I think that's a conversation I think just has to elevate a little bit more. And we're starting to see more and more of it, but that is where you sort of need, deeper collaboration to make that work.
Indeed. And that's really where, in some cases, software and solutions that maybe creatively work around some of these challenges enable us to do a little bit more than we might otherwise be able to in those regulatory environments, like maybe understanding, let's say, the specific localized environmental regulations, or understanding what the constraints actually are, and try and deliver that flexibility with the other resources that you might have at that site.
Yeah, good study by Duke University on that topic of terms of the extra capacity that's available. Again, I don't want to say like, oh, it's easy, right? It's not easy. You still have to ensure that there is a reliability metric in grids, and they still have to iron out some things to make sure that there is some equitable management across this area. But there's more that can be done, and it does take a little bit of collaboration across India, which we'll talk about partnership.
There is some. I mean, the regulators and incoming chair for NARUC is Ann Wheeler, and I think it's Whelan.
Yeah.
Sorry, Ann. But, they are really focused on trying to figure out how to do it, but just not hurting the consumer, and it's a hard thing.
Yeah.
And it comes back to that point I was saying there. Everybody's trying to solve for the problem, but doing it from their own mindset, which sometimes takes a little bit longer to get to the outcome.
And we've certainly dealt with, I'll say, decades of skepticism in the regulatory environment about, the assume that there's something bad going on, and that actually, you look for the negative angle.
Well, glass half full.
Yeah,
glass half empty. Yeah.
Hey, look, I want to change gears here and talk about, the next piece of this is around sort of innovation and efficiency. Dave, Uplight focuses on grid flexibility and load management. You've been doing this it's been done for a while. It's been done for a long period of time, but the software has evolved. The real use cases evolved. It's no longer, hey, could it be done? It actually can be done with smarter demand response systems that can help balance this surge use in power. Tell a bit of kind of, what are some of the complexities, and what's the reality of that versus maybe the myths for the audience?
Yeah, totally. So I think in light of some of the challenges that we just talked about, what is really exciting is that we do have solutions that have actually been in market for decades now that can start to help and sort of nick at some of the challenges that we've got. So if we think about what we mean by this load flexibility, what we're able to do now, and when we think about like current demand side management in today's era, we're looking at a lot of really, really precise forecasting, both like on a longer term basis, like tomorrow, but also in the short term, and also thinking about things like the optionality of what happens when you start to make changes. So as an example, I might forecast what, let's say, a data center needs and what other flexible resources that might be near that point of interconnect might need. And then I can start to make decisions to say, well, if I do this thing now, how does that change my ability to respond to something later? And when you start to operate where you're looking at not just the forecast of what will happen, but what will change when you start to, capture and request this flexibility, then you can really start to create a system where these feedback loops happen much more quickly and much more cohesively. And this is where we can then get to points where we're seeing some of our customers, as an example, able to deliver flexibility back to the grid, but not necessarily even notice it or feel it in their home, in their business, and hopefully their data center in the future. And what this comes down to is thinking beyond just the types of resources that have historically been part of load flexibility programs. So one of the things that, if we think specifically about data centers as well, like what are the other things that we can control beyond just the compute? What are the other things that can be co-located or near located that might be flexible resources to help mitigate those peaks, right? So I guess all that's to say that absolutely we have all of these tools today, but I want to also flip and say that at Uplight, a lot of our customers are utilities. We do have a lot of non-utility customers, but for our utility customers, we're seeing them go a lot closer to the grid edge to deal with both system but also localized constraints. So what this means is that companies like my own are starting to build a relationship with utilities showing predictable load response that then help with these flexible interconnections, because now all of a sudden, when we're maybe operating a private virtual power plant or helping inform, let's say, that data center around how it can best manage that interconnect constraint, we can also provide that visibility back to that utility in some cases in ways that then maybe make that process a little easier. Again, the practicality is that there are regulations and in regulatory environments and utilities, it still is asking a lot to do this, but we're starting to see this in play right now.
Yeah, that's good. And keep up that angle, because again, that access and communication with the utilities are really kind of what matters. Open the eye, see what's possible, and then we can adjust the regulatory environment as well, which is not easy to do, but it's there for sure. Yeah. Elliot, so you're closest, or you're all close, but close to the molecules. You're building stuff, right? So I want to know, just from kind of an innovation perspective, what do you see as sort of the top things that you see? Could be on cooling, could be server design, could be anything in that space. What do you see as kind of the top innovation that you see having the most impact on this issue, whether it be for scaling, for efficiency? I just love your view on that. And actually, I want some other views on that too. So go ahead.
So for us, I'm lucky because we build hardware. So I get a look-see into what the hardware is for the next 5 years and get an understanding of the hardware. So I see it in 3 different tranches. There's the hardware, the GPUs. So at that level, there's a lot of efficiency that can be gained by removing the fans. Like we already went direct to chip. There's more that can be done to make it more efficient. We're talking about 5 to 10%. This is a big number in the kind of numbers when you're talking about gigawatts. The next level, when we're looking at the data center itself, a lot of optimization has already been done in the last 10 years. We're trying to scratch for 1%. But one thing I think is critical for the future is heat reuse. So using the massive amount of heat we're generating through the data center through 3 different main applications. There's district heating, which that's very localized. It depends where you are. The second one is for farming, helping farmers farm, all year round 365 instead of in seasonality, right? And the third is for industrial processes. One industrial process, for example, we're looking at very deeply is carbon capture. Carbon capture itself requires heat to release carbon from whatever medium you're using. Why not use heat that's already being generated and you're just being exhausted at this point? And the third one is going into the grid and some of the interconnections with renewable energies and other things. One interesting point we've been looking at a lot is if you look at, for example, a solar panel farm, where its peak is when it's the hottest day and it's the sunniest day. That's when a data center has its largest peak. If you work to manage those together, you'll get some interesting results. Instead of just pumping in, a ton of renewables where you'll have times where you're not using it. In California, there's times where you have a ton of power, no one's using it. Be smart about it. Be more transparent about it. If we're all communicating about, this is what my load looks like. This is what, if you look at the utility, this is what I can provide. If we work together, we'll get a better result. Then there's another dynamic when we get into the hardware is that AI workloads have particular demands. You might have heard this. You have peak loads on a GB200 or other types of GPUs. There's a ton of technology out there like capacitor-based systems, supercaps that can help resolve this. But it's really an open and transparent conversation that has to happen today. We're asking so much that the best way to get this done is all stakeholders come to the table. Like we say, carte ouverte, or like we're really talking real things and getting problems solved.
I loved that. Brought the little Canadian in there. I like it.
Quebecois.
Yeah. Oh, sorry. I made a mistake.
It's all good.
Yeah, I'm okay. I'm on this end of the stage. It's okay. It's okay. Yeah. So what's interesting is you kind of hit upon a theme, which you mentioned things that were across the full stream. Heat recovery, heat reuse, to down to the chip level, or at least the server level. AI smoothing, and that's an interesting perspective of innovation and new things, because it really isn't in one space. It's really not a magic bullet. It's kind of looking at it as a system. Chris, you probably have the richest history in kind of system design. I'm just curious quickly on picking your brain on innovation and kind of what do you see as the top most promising vectors on innovation dimensions?
So I think it's about a couple things. How can you have a fleet style scale?
Yep.
Okay, so how can you do things at scale consistently without having to relearn every single time?
Yeah.
How do you create a environment that allows for there to be a very long-term asset but then deal with equipment that has a very short lifespan?
Yeah.
So how do you build that type of environment? I think the innovation around those things and making sure that the one thing that's a constant in IT and in the world that we live in is change, and it's never an or, it's always an and. I'll give one exception. Learning factories, right? AI learning factories are much more like a Bitcoin crypto. we should not call those data centers. That's why you see focus for the AI factories. That is a point in time. We don't really know how that's going to look long term, what that world's going to be long term. Super important for these LLMs.
Sure.
You've got whole other schools of thought that say, I don't ever want it to be an large language model. So you got to delineate between the data centers that are running the economy and then the data centers that are training to go into those facilities. Yeah. And so I think, how do you do that stuff at scale? I mean, how do you move racks in? How many trucks does it take to line up? I mean, the amount of stuff that's really cool businesses. How do you pull a 7,000 pound rack? Yeah. My team was doing stripings for a 5 megawatt row. That's a lot of stuff. So the sheer scale of what's going on, I think is awesome. And we at Compass, we really love trying to make the scale stuff easy. Yeah. And I think that's where we have most fun in our innovation.
Done a good job with that as well, I think. And the reason I also wanted to poke that question in is really because it's not, we think about innovation, we think about things like technology and space, but it is actually around process scale. There's so much to be done. You've done a lot. I mean, not to just, toot your horn there, but there's a lot with regard to just how do you do this? How do you do things at scale efficiently and effectively? Plenty of room for innovation across the whole board, not the least also on contracting and regulatory and even the ability to kind of enable things to happen as well.
Yeah, totally. And maybe just one last point too with innovation. I think what's exciting is some of the innovation that we're talking about not only solves the immediate problem of interconnection and building all this capacity, but it changes the economics of what is happening in the data centers. And I think that that's really exciting to think about then what that unlocks, both from innovation, but then also from just all the services and empowerment that brings all the beneficiaries of AI and data centers in general.
Cool, that's good. So look, I want to switch gears a little bit. Again, we're kind of gearing through our transmission here. I did want to talk about the role of strategy and partnerships. And I wanted to highlight, one aspect of strategy, which is around site selection and sort of an energy strategy. And again, Chris, I'm going to, go to you on location strategy become, almost as critical as, compute strategy, whether you're building for somebody or you're actually trying to deploy that. How do you see sort of energy availability and maybe sustainability shaping where AI factories need to be built? And how do you, just what's the strategy you think is appropriate for the industry, or maybe it has to be segmented based on a hyperscaler or something?
Yeah, I'll use Canada example. So the Maple 8, which are the big Canadian pension funds, which one of our owners is one of them. I was speaking to them and a couple of years ago, or a year plus ago, and there was like, how come investment isn't coming into Canada on this stuff? Mm-hmm. And it really boils down to the sheer scale of the capital. Capital always flows to its easiest pathway. I mean, it's going to follow the gravity. And when you make things very difficult, when you look at the size of the investment that goes on in these communities, these are transformative investments for the entire economies of these areas. And there is a lot going on right now in the funded protest world. There's actually funded protesters that travel around, sit in zoning meetings and say, no, we hate data centers. Mm. There's a whole thing of where do you make it easier and where do you make it harder? Mm. If our clients do multiples of our investments, we invest $5 billion in a campus, they're probably at 25, right? I mean, so it's like crazy numbers because their stuff refreshes all the time, right? Yeah. Building that structure on the front end. So when you talk about that type of investment, I mean, these are like, you just watch entire places transform. Yes. Site selection really boils down to having great relationships with utilities that are forward thinking. Yeah. Southern Company I know is here, Chris Womack and team, like they've come up with all kinds of creative solutions in several of their regions with us. So when you can get to that glass half full mentality versus the glass half, and I think it boils down to communities. If I was in the 1800s, I'd be like, oh, I don't want that noisy railroad going through my town. Yeah. That's great for you and your generation, and it sucks for everybody that follows.
Right. No, it's that understanding of like going where it is easier, from a capital investment, but also where there's less friction. If utilities, you said the Southern Company is, it's a welcoming environment. So finding a strategy that actually is aligned in those dimensions versus trying to,
because we're not selling. we're holding it forever. And so we want to be part of that community.
Yeah, exactly.
We want to be a pariah.
Yeah. Sometimes I think it's viewed that way. Yeah. So look, I also want to talk about the collaboration, across sectors a bit. So in the theme of partnerships here. So I want each of you to kind of weigh in on this because you have, different perspectives. But what types of new partnerships, or maybe it's strengthening existing partnerships that you see really should be focusing on between utilities, governments, when I say government, it could be state, local, or federal, and tech firms, that are going to be necessary to drive the next, or the current or the existing wave that we're on right now. And in building data centers that are reliable, they are responsible with their carbon emissions, but also can deliver the speed and scale that the industry is concerning as well. I'll start with you, Dave. Just give a quick your perspective there.
Yeah, totally. I think coming from a utility perspective, I really feel that some of the partnerships here to work collaboratively with utilities, right? Because utilities want to be able to interconnect these loads. They want it to be seamless and easy, but they also have constraints, right? So basically working and collaborating in a way that then allows those constraints to be managed that works for both parties, both today and in the future, I think is really important. But then to do that, that's where I think some of these technology partnerships become very important, because in order to solve for some of the problems that it would take to meet the needs and constraints of each party, you'll need to make sure that there's data visibility, make sure that there's that reliability around if this is a dynamic constraint that is going to be there to enable this interconnect, are we sure that you're actually going to be there and do that and follow that shape, right? So I would say that that's probably a really important part, especially for the short term.
Chris, what's your views on the what new or existing ones you think have to strengthen on that collaboration side?
So for us, we've taken this thing of a vision of using a manufacturing approach in everything that we do. And that generation of manufacturing was from Deming, and it was kind of the old Toyota way, and what we call a very closely coupled supply chain. It means that you have partners. So who are folks that weren't in my partner category, like a Schneider who was in our partner category? Well, utilities, that's something that we've leaned in very heavy in, and we've invested a lot. Cliff, who runs our team, used to be with Duke Energy, run a strategy. And so we want to be partners with them. We want them to know that we're looking out for their interests. We want partners with our financial partners. They're part of our supply chain because we require a lot of capital.
Yeah.
So we create those elements there. And, we're continuing to evolve our partnerships, deepen them with the groups that we have, but we're also now starting to look at how do we partner with NARUC, with the government relations elements that need to happen.
Yeah.
They're necessary, and being a clarion in the wilderness about being good community partners, there are quite a few data center folks that really try to do good things for folks, right? And there's some bad apples, as there are in every industry, and that's what you need sensible regulations for and laws for. And there's a lot of people wanting to do good. So we're trying to partner with grid operators to introduce the concept of proffering into the grid, where we could make an investment for public good. So, your territory needs batteries for this, or you need a new switching station that you can't afford. We would love to have the ability to contribute to that for the public good. And I think a lot of the data center, the best companies in the space, are very willing to do that. And so you're coming to the table with checks ready to help.
Yeah.
Because we do proffering in real estate all the time. If I want to get something zoned and entitled, I may have to build a school or do an off-ramp on a brick, to do infrastructure type things.
Yeah.
And so those concepts, I think partnering with government and trying to figure out how to do that, while I've been an unwilling participant, we've hired some great folks that can do it.
That's great. Elliot.
I'm actually going to start on the governmental level. So it's really in education. This is a space that's moving much faster than a government can move.
Yeah.
So it's in education to understand what's the benefits of having an AI cluster near you. And I'm not talking necessarily with the tents and all that fun stuff, but a real investment that's a long-term investment, how it helps the community, how it helps knowledge in AI. And it's the tool for the future. It's like, in construction, imagine you only had shovels, no bulldozers. We'd be pretty far behind. That's the kind of shift we're talking about in AI. Then coming down to the utilities is, again, partnership. You have to work with them. You have to show your loads. Like, what is it you're going to do to their grid? How do you help? We have to find unique and good ways to work, innovative solutions to solve the problems. And there are many ways to help. Like Chris mentioned, Why don't we upgrade some of your infrastructure? Let us do that. Let us get you where you need to be able to service us and your other customers. And then going down to the technology partner is really to be that bridge. We need to be that bridge. We need to be that bridge all the way from, government utility to the technology partner. They're designing chips to do better, to do more, to try to push the boundaries of what is possible in training models and other inference models. But you got to keep in touch all these points in the chain. If you don't, and you're just building in a vacuum, you're going to build something that's not possible to install. So it's important to have that feedback loop and a really open conversation.
That's great.
And imagine being able to then take maybe that battery or asset that is being sort of contributed to the community, and then also unlocking value from that for the utility outside of maybe the help that it provides the data center for that interconnect. Really,
good value for all aspects. So look, we're kind of winding down here, but I do want to do a little bit of a quick top of mind type thing, and just talk a little bit around kind of, hey, in one sentence, what would be the single most important thing that we should be doing today to help us sort of navigate this ramp that we see in the future? Give me a one sentence.
Yeah, I would say for me, it's just looking at sources beyond, looking for load flexibility sources within a data center and adjacent to a data center beyond what we've maybe traditionally thought of. So it isn't just, let's say, tapering or adjusting compute, but thinking about the other flexibility that exists there.
Okay, good. Chris, what's your thoughts?
I think it's stay humble from the standpoint that there's so many disciplines it takes to be successful in this business.
Yeah.
You can't assume intent across educational issues.
Yeah.
And there's a lot of educational issues that people, are in certain disciplines, but not in others. And this is the ultimate cross-functional, touches everything. And so I think staying humble is very important.
That's good. Good word, humble.
So just to jump on it, it's better utilization of resources. We have a ton of resources, whether it's heat, whether it's, power spikes that are, causing issues. Better utilization of resources across the board, across all the levels we're talking about, will definitely give successful results.
Oh, that's fantastic. Look, I really want to thank all of you. Some of the takeaways here, you can get a sense is that I love the different perspectives. If I had to do this again, I probably would have the Southern Company here as well, because it bring all those dimensions. But you can kind of get a sense that there is a willingness and opportunity to solve the problem. There is likelihood, more capacity that we can get access to with better collaboration, with better understanding of our assets, with a better framing in that space. It's not innovation in one thing. It is more that system approach. And again, this whole being humble and understand that, there's different perspectives here, and how those different perspectives have to collaborate to kind of solve this problem is really where we're in today. That'll become more natural, I think, as we come forward, as you heard from our panel as well. So look, thank you very, very much for your attention, for your comments, your candor, as you're always good at doing. Fantastic insight. I do encourage all of you to go visit the data center hub downstairs. You'll see the whole grid to chip, chip to chiller from a Schneider perspective, but also kind of you'll hear these elements that you heard of this panel session today kind of brought to life, and see what's feasible there, as well as the whole park itself. Lots of interesting things down there. That's kind of what this is all about: collaboration, networking, and understanding. Thank you very much for your participation and your open views on these topics, and looking forward to seeing you around in the next day and a half now. Thank you very much.